Okay, now what we are doing, we are showing the mechanism for a tensile testing. So we are applying a force P, the cross-sectional area is A naught. After applying the force, say this is my scenario. I made a bigger sketch. Say black one is initial shape. After testing it, the length will increase and the lateral dimension will decrease. Say my increase in length is delta L by 2 this side, delta L by 2 that side. So total elongation is delta L. We know that axial strain is defined as total elongation divided by original length. What is original length? That is the black portion. It is my original length or gauge length. That is called axial strain. Next is axial stress. Axial stress. What is this? This is whatever the load I applied divided by the initial cross-sectional area. Now these two definitions are engineering definition. It is not true. What is true? True means we should not use the original dimension. This A and this L naught, if we use the current or the final, then it will be true stress or true strain. That is the difference between engineering stress, engineering strain, or true stress, true strain. But we mainly use engineering. True is just a definition, concept. Now something else you can see. So my lateral dimension is also decreasing. Say this side decreases delta D by 2. D means diameter. So this side also delta D by 2. Original diameter say D naught. Then in lateral side or transverse side, I have some lateral or transverse strain. What is that? Lateral decrease in diameter divided by lateral original diameter. So that is a new term. It is called it's a transverse or lateral transverse strain. Is epsilon t change in diameter divided by original diameter. Or you can use that other way, change in radius divided by original radius. Now if it is not round, say a plate, then you can take a size, change in width divided by original width. Or you can do other way, change in thickness divided by original thickness. Whatever way you define, whatever measurement you took is up to you, all are same. So change in diameter, change in radius, change in width, or change in thickness, everything is same. So hopefully you understood axial strain in this side and you understood transverse strain. If I apply tension force, axial strain is positive, transverse strain is negative. Why negative? My lateral dimension decreases for tension. In compression test, this will be negative, lateral will be positive. So lateral and axial always opposite in sign. So now we will define a new parameter which is called Poisson ratio. Okay, I'll go to a new slide. Hopefully you wrote it down. If you did not, 2 more seconds. So Poisson ratio, Poisson ratio. So we use this symbol mu. It is ratio of transverse strain divided by an axial strain. Ratio of transverse strain and axial strain. Yeah, and this will be a negative sign. Now why negative sign? Because either any of this is negative. And now sometimes we are lazy, as this value is always negative, so we discard it, we do not consider it, but we know it, it is in our head that Poisson ratio is always negative. But in your book you may not see negative sign, because why? Because we know it, and every time writing a negative number doesn't look good. So we always try to use the epsilon, the value only. We do not consider the sign, but again remember there is a sign. Now this value is always minimum value 0, maximum value is 0.5. Say water is 0.5. 0, there is no value is 0, but I can say diamond. Diamond is very hard, very difficult to, uh, again diamond is not 0, but I'm just giving you an example. Diamond is very hard, you cannot deform it after applying load, so it can be assumed 0. So I should say this side, just to tell you the difference. Diamond 0 and water is if you press water it goes lateral way very easily, so we can say water. So in your FE exam you might get this question: what is the maximum value of a Poisson ratio? Maximum value is 0.5, always 0.5, whatever it is. Minimum value is 0, so memorize this number. Why? Sometimes a question may be asked, which of the following is the Poisson ratio of, say, mild still? Okay, option number 1 0, option number 2 1.2, option number 3 say minus 0.2, option number 4.3. So question is Poisson ratio of steel. Steel should not be 0. 0 means like water. No, 0 means like very hard, we should not deform. So it is impossible. Second is impossible because it is more than 0.5. Nothing, Poisson ratio cannot be more than 0.5. So not 2. Now two numbers, 0.2, 0.3, both can be answered. Now if you say, I am guessing that you do not know anything. That way, how can you pick the answer? You know that Poisson ratio is always negative, and these both can be answered. So this is your answer. Now it is positive. Poisson ratio is always negative, but sometimes we omit the sign. But if they put the sign, that means they are uh, giving importance in the sign. Now other question is, so answer is C. But if C was 0.2 and D was 0.3, then which one is the answer? No. Then you have to know the answer. I know that for steel, um, the Poisson ratio is roughly 0.15, so this can be answered. But again, to pick answer from these two, you must know it. I'm just giving here example. If you do not know it, how to eliminate an answer? 0 not possible, 1.2 not possible, positive not possible. So this is the answer. And now this is not an ideal case. I'm just giving you an example. Sometimes you can find answer by eliminating option. Okay, so Poisson. Okay, so let us start. Let us solve a problem on Poisson ratio. In your handout, it is going. So, oh, I made it when I open the handout. Sorry, PDF file and Zoom, it doesn't work. So what I will do, I will open the Word file. Word file works. Okay, so now we will solve an example on Poisson ratio only. Okay, we will go. Okay, here. So this example, a tensile force of 100 kilonewton is applied. Now what is this 100 kilonewton? It is the force P applied on a 0.02 meter diameter and 2 meter long rod. So 0.02 is your D naught initial, and 2 meter is your L naught initial length. After applying the load, the diameter of the rod decreases to 0.01998. So this diameter is the final diameter, and the length increases to 2.01 meter. This is the final length. Calculate the Poisson ratio. So we know Poisson ratio is a ratio of lateral strain by axial strain. So we need to find lateral strain and axial. Lateral strain how? Delta D by D naught. Final is this minus my original. Then I will get this is the change in diameter. This D naught is our original diameter. Then we got the strain. It's a negative number because it's a tension test and lateral dimension will decrease. Then is the axial strain, delta L. So this is my final L, this is my initial L. The change is delta L. That is the change divided by original. Again, always divide by original, because if nothing is said, that means engineering. I told you earlier that true stress, true strain, we never use it. It's just a definition, just a concept. If the problem says true, determine true stress, that is a different story. But if nothing is said, that means it's engineering. Okay, so we determine lateral strain, axial strain. Now, should we take the decimal uh, or the percentage? Doesn't matter, because it is all about the ratio. I do not know why I determine percentage. I do not need it. Then we took the ratio and we got 0.2. So answer I wrote, you can see 0.2. I did not write negative, because everybody knows, every engineers in this world knows Poisson ratio is always negative. You tell it or no. Now hopefully you understood this example. Very simple example but very meaningful. In FE exam there is a very good chance that you will get a question similar to this stress strain. Okay, the next example maybe not Poisson ratio, something else. Okay, next example, we did not cover the theory.